All right, so hello everybody and thank you all for joining us for tonight's webinar. So tonight we'll be taking a closer look at potable reuse of recycled water, which is a very exciting topic. My name is Natasha Satori and I'm a committee member on the Victorian branch of the AWA. So I'd like to welcome you on behalf of the entire AWA Victorian branch who've organised this event in partnership with University of Melbourne, particularly their Water, Environment and Agricultural platform. Tonight we're supported by Dalton Consulting Engineers and this webinar is one of our regular offerings of virtual events, and it also forms part of the University of Melbourne's broader series on water security. So just a quick note about AWA for anyone who's not familiar. We're a member-based organisation, so everything we do falls under our 3 core objectives, which is basically the aim to share knowledge, connect with others and inspire each other to work towards positive change in the water sector. So I'll just run through the order for tonight. Thank you, Digna. So after an acknowledgement of country and a welcome from our sponsor, we'll move straight into the presentation section of the evening. We'll have all questions at the end of the session. So we've got 3 speakers tonight and that will be followed by a panel Q&A session. In terms of timing, I think we've said the event will formally close at 7 p.m. So that's Eastern Standard Time for anyone outside of Victoria. If anyone would like to stay on and chat after that time, our speakers have actually offered to stay and answer additional questions. So we'll have the formal finish at 7 and then a little bonus question time after that. And just a reminder for anyone who isn't aware, this session is being recorded. So just something to be aware of, and also note that this will be made available online to review later. So before we get underway, it's really important to acknowledge that any of us tuning in Australia are meeting on the lands of traditional owners. So I know tonight we're meeting from many different places. So if there's anyone who'd like to make their own acknowledgement of country, that's really great for everyone to see where we're all joining in from. So I'm speaking to you from Melbourne, where I live and work on the lands of the Wurundjeri people. So I'd like to acknowledge and pay my respects to them as traditional owners of the land, their elders past, present and emerging, and also extend that to elders of other communities who may be here today. So a quick note, we can only have these nights thanks to the sponsors that support our events, and tonight's event has been possible with Dalton Consulting Engineers. So I'd like to welcome Julia Bauman to say a few words with you. Welcome, Julia.
Thanks so much, Natasha. I would like to acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional custodians of the land on which I am presenting today. I pay my respects to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander people today. DCE is thrilled to be supporting the AWA in bringing you this evening's webinar. At DCE, we are passionate about water reuse projects. We have been, and we continue to be, involved in water reuse projects across Australia. In 2020, DCE is celebrating 25 years. While we would much rather be celebrating with you all in person, we are happy to be able to support the AWA in providing this webinar on the critical topic of potable water reuse. Thank you so much for joining us this evening, and please enjoy the webinar.
Thanks, Julia. Great to hear from you. Really happy to have you on board. And definitely second your sentiment that it'd be much nicer to be together in person, but we're making do, and tonight's still going to be a pretty great event nonetheless. So as I said before, my name's Natasha and I'm here because I'm on the AWA branch committee. The team has lined up some really great speakers for tonight who've offered to share their time and expertise and provide some really great insights into just what potable reuse is all about. So first of all, we will hear from Greg Finlayson, who's the manager of water treatment at GHD. So Greg's bringing his extensive experience in advanced water treatment technologies, including reverse osmosis and ultrafiltration. He's worked for significant treatment projects, notably as a key author on the feasibility study for the Victorian desal project. So Greg tonight is going to take us through some of the big picture overviews surrounding potable reuse, including urban water supply and demand trends, both here in the US and Australia. And he'll also explore some of the technical, financial and political factors that go into selecting treatment methodologies. Following that, we will hear from Professor Peter Scales, who is an honorary professor at the Department of Chemical Engineering at the University of Melbourne. So Peter's research is in process and systems optimization, and he's got a keen interest in the future of water and wastewater systems in our cities. His research is focused on recycled water for productive use, as well as breaking the pollution cycle in wastewater processing. And Peter is going to take us through the science and what is essentially the how question of wastewater purification, including its safety and a bit of info on how treatment technologies are currently evolving. And then to wrap it up, we'll hear from Dr. Anna Kosovac, and she is a postdoctoral research fellow in international urban politics at the Connected Cities Lab. And she brings her breadth of experience in the public water sector across engineering, strategy and planning fields. Her current research is looking at decision-making and governance and a focus on the uptake of innovation projects in the public water sector. So she's recently undertaken studies on risk perception towards potable reuse, and she's going to share some of those interesting findings with us tonight. So might keep things moving. Just a quick note before we get underway, please feel welcome to use the chat function. Welcome to chat with each other and engage with the panelists. As I said, we'll be basing our panel session at the end on the Q&A questions. So if there's something you'd like addressed in the panel, please make sure you put it in the Q&A section rather than the chat section, and make the most of the vote function as well, so that we can try and get to all the most popular questions. And also just a reminder for anyone who's not very familiar with Zoom, that you can choose your preferred viewing option. So you've got the ability to choose between speaker or gallery view there. So I think we'll get underway with presentations. So first up, we've got Greg. Thank you, Greg.
Hi, everybody. Can you hear me, Natasha? Just checking it's all working.
Yes, we can hear you great, Greg.
Okay, that's great. I just wanted to start by, of course, doing the acknowledgement of the country as well. I'm in the same place as Natasha. I also wanted to say, as a sort of a joke to start with, that I'm a bit disappointed that the hundreds of people who are here online are not appearing in front of me in fake seats. My son follows the NBA, the basketball, and it's quite funny to watch the finals there where the stands look like they're full of people, but the people aren't really there. They're all people who've paid to have their faces appear in the stands. So that's something perhaps the AWA could look to do in future as part of its sponsorship. So I'm going to talk, I hope pretty briefly, to provide a bit of an overview of why it is we're concerned about water in our cities and how potable reuse might fit into that. So I'm going to run through just 2 or 3 really obvious points here, but try and really get them into your heads for when the other speaker speaks. The first thing is that in big cities in Australia like Melbourne and Sydney, we're growing our populations really fast. In fact, for both Melbourne and Sydney, we expect the cities to be about double their current population in 50 years. And this is a really big deal because in practice, our infrastructure, our water infrastructure that we have in our big cities is pretty much at capacity now, plus or minus. So somehow or other, there's a lot of stuff we've got to build to deal with all of these extra people. So there's a lot of big decisions we have to make, and that's where potable reuse fits in to those big decisions. The second point is, which I imagine everybody's pretty familiar with, but I'm going to show you some broad data on it, is that we currently use, in Australia at least, and also in a lot of other places in the world, primarily water from the surface, water that's stored in dams, and that water is getting much less reliable, rainfall's dropping. This is all due to climate change as well as other factors, and that means the amount of water we can get even today is less than it was in the past, and that's a bad combination with a growing population. And the third point, which actually I feel is one that's not talked about enough and I really wanted to emphasise tonight, is that some of these options like potable reuse and some other options actually offer us an opportunity to actually do better by our rivers. We should be taking less water from our rivers than we do now to protect them. And these new technologies give us ways of getting new sources of water, which means we've got an opportunity to provide those protections. Can I have the next slide? So this graph comes from, in Victoria, a thing called VIC 2019. And it's a pretty dramatic graph that's sort of hard to look at without being a bit startled by if you pay attention. So what that says is that Melbourne's population is expected to be of the order of 9 million in 2056, currently about 5. And we've got to remember 2056 is really not that far away. That's only 36 years away. It's not even 50 years away. So that's a very, very big change in population in a relatively short amount of time. So the next slide. So I'll spend a moment on this picture. This is a picture that people who work in water resources are very familiar with, these kinds of pictures. But what this is illustrating, and this is from Melbourne Water's system strategy, which is online if you want to go and read it. It's a great document. It's got a lot better information than I can present really quickly now. But what this shows is the inflows into our major storages in Melbourne going back a long time. And if you look along here, there's a rolling average, a 5-year rolling average, which if you look at the more recent years since of the order of 25 to 30 years, there's actually what appears to be a step change in inflows. And if the most dramatic of those changes is considered, which is the one appearing there in orange, that's a very significant reduction in the amount of water that we think we can reliably get from our water supplies. So if you add that fact into an increasing population, you can see there's a very good chance in the future we're going to have a shortfall of water from our surface water. And in fact, as it happens in Melbourne at the moment, we're running the desalination plant in Melbourne pretty near to full capacity already. So we haven't even got much room to get extra water from the assets that we've already built to deal with this problem. If we go to the next slide. So this graph is a graph from Perth, and I like showing this picture to people because it illustrates an even more dramatic change. So if you look at the top line, that's the amount of water that Perth used to be able to get from its dams on the average up until about 1975. But the average from 1975 till today, which is quite a long period of time, is that pink line, which is less than half. And then if you go down the bottom, some of those lines lower down are actually the annual amounts that they got in different years in the last few years, which are dramatically lower. And so Perth has relied on building a number of large new sources of water, largely desalination plants up until now, but they're currently operating a slowly increasing IPR scheme, which we'll all no doubt talk about a bit. But it's just useful to look at this picture and imagine that, what if this happened to the city you're in? And I presume those of you who pay attention to water news will have seen that Cape Town had a similarly dramatic problem in recent years, which is a very big downturn in the amount of water they had and finding themselves scrambling to find a new source of water. The next one. So I've really rushed through that because I'm presuming in the water industry everybody's familiar with the fact that we've got a problem we have to solve. And I think the phrase that's important here is the need for water security. You could use another word if you like, resilience. And what those of us who do planning, which is largely the work I work in, are concerned about is to make sure as best we can that we're going to have reliable sources of water into the future. And this is really important because more and more work we do shows that having a good, reliable sources of water available in our cities is critical to the livability of our cities. Our cities need to be green for us to be living in them in the way we want to. Temperatures in the cities go down if they're green, and to make all that happen, you need sources of water. Now, as it happens, there's lots and lots of different ways we can solve the broader water security problem. We can have more rain tanks, we can do stormwater harvesting, we can do demand management, we can try and build our cities in new ways, we can do dual pipe recycling, we can in some places find groundwater. But if what we're talking about is a big growth of population, there's a very significant fraction of the new water we need that people need to drink, or at least if not drink, to go into their houses for what we call potable users. And we want those sources to be really reliable, and therefore we really need them to be rainfall and climate independent. So if you want a rainfall or a climate independent source of water, where are you going to get it in a big city? Well, there's two places you can get it. First, all of our big cities produced lots of wastewater, and therefore recycled water is a big, constant, always there, reliable source of water. And then the second large source of water that's available if you're close to the ocean is seawater. And I've said ask me about groundwater later in the questions if you're interested. We can move on. So I just wanted to illustrate something here very, very quickly, which is, let's say we were trying to solve the problem in a big city of how we would get this rainfall independent source of water. And two of the options that would be on the table, or are on the table in many cities around the world and in Australia, are on the one hand seawater desalination and on the other hand potable reuse. And they're nice options to talk about at the same time because there's lots of ways in which they're pretty similar. Neither of them are reliant on rain. That's a tick. They're both reliant on complex membrane-based treatment. There's some other details, I'm sure Professor Scales will talk about more, but in a way they both require much more complex treatment plants than we're used to. In both cases, the source of water is generally speaking low down in our cities, and we need to pump it a fair distance and uphill to get the water to customers. In both cases, we end up with some sort of waste stream to manage. They both use quite a lot of energy. Seawater desal uses more than potable reuse, but both of them use a lot more energy than our current sources of water. And they're both, compared to our current sources of water, quite a bit more expensive. And actually their costs are pretty similar to each other. If we go to the next one. So when I say the costs are similar to each other, usually in the past I had to explain why I think that. What's really great is that WASA have produced some very good reports recently, and one of those reports includes this graph, which shows the relative costs of different sources of water. And those two that are right next to each other there are recycled water for drinking and seawater desal. And you can see that those numbers are not that dissimilar from each other. And actually, I would argue that when they're that close, it's going to be situation dependent which one is cheaper than the other. If you have to build a longer pipeline or get a longer power supply or pipe it a lot more back up to a reservoir, whatever those differences are, will probably mean that any specific city, those numbers would move up or down enough to be within the error bar of each other. So their costs are pretty similar. We move on. What's different? So the first one is that at its most simplistic level, desal has a lower risk source water. There's less pathogens in it, less things of concern. That's the primary difference from a risk point of view. Potable reuse produces significantly lower volumes of wastewater. You produce a lot more brine from a seawater desal plant than the volumes of waste you produce from potable reuse. The next one I think is somewhat obvious, but it's actually the case that lots of people worry about seawater desalination in the community for one set of reasons, and lots of people in the community worry about potable reuse for a different set of reasons. So I think that the concerns are quite different. And at least in Australia at the moment, and definitely in the other places I work around the world, they tend to operate in quite different regulatory frameworks. So the issues you have to address with one are quite different from the issues you have to address from each other. So from that point of view, they're quite different. So just finishing up here, I think this leads to the question people always ask, so which one would you pick? And I think the answer to that is actually not very helpful. It depends. It's always going to be specific to the city you're in, and it's going to have to take into account a lot of factors, including the really important political and community factors that speakers are going to talk about later on. So there you are, Natasha. That's me done with my quick overview, and I'll hand over.
Thanks very much, Greg. That was really interesting presentation and a really good summary of the question behind why you would consider potable reuse. So it's really clear that water security is a very significant challenge for the water sector. And really great to hear a really straightforward comparison of the pros and cons of desal versus potable reuse as well. That was really interesting. So thank you very much. And we'll keep moving right along. Next up is Peter. So thank you, Peter, whenever you're ready.
Thanks, Natasha. Good evening, everyone. Hope you're enjoying things from wherever you are. I'd like to talk about some of the, I suppose, the engineering bits, or not the why we might need to recycle, but how do we do it? And At one level, one could argue that there's not a lot to know here, because in actual fact, there's been various places doing it around the world for more than 40 years. Namibia, South Africa, Belgium, Singapore, USA in a number of spots. And the ones in red in that list there are actually places that have been doing it for more than 40 years. Some of them in an indirect way, and in the Namibia case, in a direct way. Typically, what they're doing is doing what we call surface water augmentation, which means that you treat secondary, you treat wastewater, and then you put it back into a surface water supply, or you do aquifer recharge. And to work out why or how we do this, we generally use what we call a risk-based approach in terms of design and operation of a plant. And there's a number of guidelines and regulations that sit around the world. And in actual fact, Australia sits pretty well in terms of what's available in the world. There's WHO potable reuse guidelines, the Australian guidelines for water recycle, and California Title 22 regulations, all written a bit differently, but with a risk type analysis as their base. And in designing and operating a plant, an advanced treatment plant, to actually take water and put it back into a potable form, you basically take a risk-based approach where you just use a series of barriers, and each barrier actually removes a certain amount of risk. Next slide. There's lots of different options in potable recycle, and Greg has already mentioned IPR. Basically, this slide, if one goes around the outside and follows the blue arrows, you see the normal water cycle, which is that we have a river, dam or aquifer, we treat the water, we put it into intermediate storage, and most cities have significant intermediate storages. It then goes to your house, to the sewer, to the wastewater treatment plant, and then to discharge. But over on the left here, you could have unplanned potable recycle, which means that it finishes up back in the river, the dam or the aquifer, and it goes back through the process. Or you could go through an advanced water treatment plant and go through IPR, which means that we put it back into the river, dam or aquifer and retreat it back through the process. DPR, which is direct potable recycle, which goes past that dam or aquifer, and it could actually go back into a purple pipe system or Class A system, depending on where we go in the future. And that would be a different form of potable recycle, where we might have two pipes in our house, of which both are potable. So lots of different possibilities there, and that slide just covers some of the acronyms really, which is UPR, which is unplanned, IPR, which is indirect, and DPR, which is direct. And most places and systems in the world that are implemented are actually IPR. Next slide, please. To give you a feel for what the risk is, and the risk you have to design out, and then in an operational sense, I'm going to put this slide up, and it's a quantitative microbial risk assessment study based upon how many log reduction of pathogens you need, in this case a virus, to achieve a 1 in a million chance that you might get sick under the worst case scenario. So in other words, in Melbourne, you might get 5 people sick from this in the worst possible case scenario in a year. The graph shows a cumulative number of virus you would see if you went to a wastewater treatment plant, and the curve on the left is what you actually see typically in Melbourne over time. So if I went to Melbourne's wastewater treatment plant and I looked for norovirus, I'd see a median value of about 10 to the 6 virus per mil of water. If I if I had an outbreak where a very large number of people in Melbourne got sick and I went to the wastewater treatment plant, we predict in actual fact that that curve would move to the right substantially, such that you might actually see around about 10 to the 10 virus. And if we were in a small community that met each other every day and we had an outbreak, it would be even worse. In actual fact, the data here is based upon a study from a cruise ship, which in the concept of pandemic and outbreaks, we all know a lot about in the last year. And in actual fact, you might see about 10 to the 11. And the way that we look at the risk profile is that we say, under the worst possible scenario, how many log reduction does these barriers need to achieve to make sure the water is safe? And typically for a big city, the number is around about 10 to the 10. You could say there that at a 95 percentile, somewhere about 10 to the 11 is what you would need. California says 10 to the 12, and if I was in a really small community, I might need to do 10 to the 13. That's a huge amount. That's a 99.119 reduction. Along with that, I've got a risk due to chemicals, and we use about 8,000 chemicals regularly in our lives every day, and they finish up in wastewater treatment plants as well. Next slide. So I know what the risk is, and we do those curves for different types of pathogens, and we do a similar sort of thing with chemicals, and we say, okay, well, what do the barriers have to do? And this is then, if I said to you, okay, I'm going to give you a set of Lego blocks where every Lego block gets a certain credit for removing some pathogens, and I have to add enough blocks together to make sure that my plant actually achieves the outcome, then what we do is, as an example, we take the barriers, and on the examples there are a whole set of different barriers, and they have different removal functions. So I'm going to color the blocks different colors, and each one, and this is just an example, it's just an example I've taken from a piece of work that we've done, but you can get different credits for different scenarios. You get a virus credit for, say, microfiltration, you get a virus credit for ozone or for reverse osmosis or UV or chlorine or aquifer storage. And we might say down the bottom, we require that our barriers have 10 credits all up. For virus, 10 for bacteria, 10 for protozoa, and say 1.5 for chemicals. Sit down, put a set of barriers together that gives me that, knowing that that is the absolute worst case scenario, and in actual fact these barriers will operate to a higher level than that, but in doing that we would then effectively have a plant where the risk that you would see a pathogen or a chemical from the water is extremely low. And if you have at least 3 barriers for pathogens, 3 for chemicals, you can use aquifer storage as a barrier, then you can go and design the plant. And it says that I could have lots of different styles of plant with lots of different barriers, and I could still be safe. Next slide, please. So as an example, if I take that and I go to the Western Corridor project and the Perth water replenishment scheme, and I look at what barriers they've used, and if I was to add their credits up based upon those barriers, Western Corridor uses microfiltration, then RO, then UV peroxide, and then chlorine, and then it goes back into surface augmentation, back into a reservoir. Perth uses a UF, a RO, a UV, and then goes into aquifer storage. And you can see, if I was to sit and add them up, they would both achieve a 10, 10, 10, 8 and chemical credit system that is fine. And yet they're slightly different plants, but they both would remove the risk entirely from this water. Next slide. So challenges and conclusions are that this is a fast evolving area, and people like Greg know all too well with membranes. In actual fact, some of the new nanofiltration membranes can exceed 6 log in terms of their performance. And so how we monitor those is now a problem. We haven't got barrier credits for chemicals. We tend to do that, I think, poorly as a community still. And if we had them, it would be a lot easier for people to both design and operate potable recycle. But the practice around the world has shown that ultimately, if we use good regulation, if we use good credit systems, and we operate these plants well, then technically recycle to potable is both a really safe and very resilient and robust method, and probably less costly, although that depends on where you are, than desal, and ultimately it's not a big technical problem. So thank you, and that's just a bit of a very quick overview of how I start to think about designing and operating a plant for potable recycle.
Thanks, Peter. Thanks for your take on that. You mentioned at the start that there's not really much to discuss with the tech, but there's a lot of us out there that really enjoy hearing the nitty-gritty of all those details. And it was great to hear your take on the concern around risk of potable reuse. So I think that's a factor that's often in front of people's minds. So it was great to have a bit of context and understand some of the different approaches to managing the water quality risk. And just for my own learning, I hadn't heard the term UPR before, but that sounds like a great marketing name for just what we normally used to call an accidental spill. So I really liked that one. Thank you. All right, Anna, so when you're ready, we'll head over to you. Take it away when you're set.
Absolutely. Thank you so much for that, Natasha. So I've been invited along to discuss this idea of potable reuse across Australia. And I'm looking at it from a bit of a different viewpoint. Next slide, please. So predominantly that potable reuse barriers are social and political, and this refers to why we are not putting potable reuse into practice at the moment. And that's not to say that there aren't barriers that are occurring at the moment in terms of technical side of things, but at the moment we're seeing a lot of social backlash and political backlash from this, and we're really here to understand why this is. So just next slide. So what I'm going to be doing today is to talk about a bit of the research that's been done both by myself and by other colleagues in the area, and looking at three main groups and looking at attitudes to potable reuse in that space. So we're looking at, I'll be looking at water practitioners, politicians, and then also the public, and then we'll be going through a bit of that information. So next slide, please. So this is a study that I undertook recently, incorporating 77 participants from across Melbourne. They are all water practitioners from one of the four water authorities. So all four did take part in this. One of the fictional scenarios that I gave them was the implementation of a potable reuse scheme. And I asked them all, well, what do you think the largest risks associated to the implementation of this type of scheme would be? Next slide, please. And this is what we found. So overall, the sheer majority had said that the highest risk was really to do with community opposition and also reputation to the authority itself. This is actually quite interesting, considering the fact that cost was a lot lower, safety wasn't as high, and it was higher even than public health. So why is this important? Well, the fact is that we know that risk perceptions are a massive influence on our decision-making day to day, and we know this from a lot of the psychological research out there. So if water practitioners are so worried about community opposition and reputational risk, then this says a lot about, you know, what's going on out there, and also the reluctance perhaps to pursue this type of a scheme. Next slide, thanks. And then I look at water practitioners and politicians. So next slide, thanks. And this is a study that I just recently completed with a couple of colleagues at UNSW, so Varsha Sivugarathan and Stuart Khan. And what we looked at was the attitudes of water practitioners and politicians within Sydney. So seeing, well, on the issue, particularly on the issue of potable reuse. And we sat down with, there were 20 of them, and we had interviews to figure out, well, what are some of the themes? What are some of the barriers that are coming into place when we're talking about this? And the key themes that came through were the disjointed water governance system. So things like having to liaise with a lot of different entities, councils, there are private entities as well involved in that, health authorities too. It just makes implementation of this quite difficult. Next to that is negative community sentiment. So one thing that was mentioned again and again in the interviews was that the community were not on board, but because they don't understand. A big part of it was, well, if they knew what we knew, then they would be on board and they would be supportive of a potable reuse scheme. And so, sorry, just go back, just one. And this also, this kind of paternalistic language was being used, especially between, I think, a lot of the experts and the politicians, you know, when referring to the public. And lastly, this idea of we need a crisis. So it's this, when I refer to crisis, like referring to, say, something like a drought, where a potable reuse scheme in comparison would seem a lot less riskier than the do nothing option. Next slide. And then this is a graph of, we asked them to rank the likelihood of Sydney developing a potable reuse project in the next 30 years. And there was a stark difference between the industry leaders, so the water practitioners and politicians. So we're looking at politicians really up that higher end of, you know, thinking few of them thinking it's actually quite unlikely, and so ranging from 3 to 10, with that mean it being at 5, whereas industry leaders are really clustered around that highly likely point. And I wonder how much of this could be also the understanding nature of how they understand the technical aspect of it a lot more. Next slide, thanks. So then we go on to public attitudes. Next slide, thanks. So I pulled out all of the studies that I could find from the last 15 years that were done in Australia and that were a representative sample, and we're just looking at surveying the public on their potable reuse attitudes. Do they support potable reuse? Would they drink it? And a number of studies, here are all the studies listed. You can see that the support ranges from about 20% through to about 50%. So the main thing to note here is that we're not really reaching that tipping over point over 50 yet, that majority, as far as we can tell. Also looking across these studies and going from 2006 to 2016, we're not really seeing a trend of either going higher or lower over time. And so, you know, wonder what this also means too. So whether the support is there. The last study that was done over 4 years ago. So really we're due for another assessment now. So that's something I definitely recommend, knowing the lay of the land right now. Next slide, thanks. So why are the public not accepting of this? Well, part of it could be psychological barriers. And this is, you know, definitely something that's present in Singapore even, where they already have a potable reuse scheme in place. So the main aspect of water that really factors into risk perceptions is that often it's imperceptible risk. So this means that you might not taste it if there's something wrong with it, you might not see it and if there's something wrong with it. And then we've known that in psychology, this shows that people are think it's a lot riskier if they're not able to perceive it. And it also gives them a lot less control, which is another thing that raises risk. Interestingly, the studies showed that education level didn't necessarily reduce perceived risks in this area. So people with high levels of education weren't necessarily more supportive of this project. But there were mixed responses in knowledge and acceptance. What was particularly interesting in this is that if people knew more about how water was treated, it didn't necessarily mean that they were necessarily going to be more accepting of it. Some studies showed. Some studies noticed a link between them, some studies did not. So it's quite a mixed bag. But one thing that I really did want to mention is that public trust in authorities, government and science is a huge issue in this. At the end of the day, to be able to convey any sort of knowledge or information, there has to be trust involved. We take on information from people we trust, and this is something we know that happens a lot. And so not only is it the taking on of information and teaching, educating perhaps, but also trusting that once that authority is in place, or once that scheme is in place, that all the right things will be done and we can trust that nothing will go wrong. Interestingly, also in the case of Toowoomba and Canberra, extra information on the scheme didn't really seem to sway public decisions and this, the dangerous element of this is that it could end up by putting too much or a certain not being strategic in the type of information you put out, or if there isn't trust there, it could create polarization of opinion if not done correctly. Next slide. And then we look at internationally. Well, what sort of support do we get internationally? And here we have a study that was done, this was done a few years ago now, in 2016, a small selection of countries. And but what we can see is that most of the support for potable reuse in the public is kind of sitting between 20 and 30%. Australia a little bit higher. But the two that are the highest is interestingly in Jordan and in Australia. And probably not that surprisingly though, both of these places have had water that's been very much in the political sphere, and also water scarcity issues that have come up time and time again. So you can kind of see where we sit internationally as well. Next slide. So basically, I'm just going to end this with saying, well, it would be very helpful to be able to, now that it's been a number of years since the last study, it'll be very helpful to have a look further into the current perceptions, but also the risk communication practices that we can use as, you know, within the water industry to be able to encourage these type of schemes. And so, and also looking at the trust element in that too. So ultimately, you know, this is something that we're looking at. So if you ever wanted to partner with anything on this, please get in contact. And hopefully we can get there within not within 30 years, but actually within 30 years, but hopefully within not too long. So thank you.
Thanks, Anna. That was great. It's a really interesting topic, and you did a great job at highlighting, I think, the interesting mix of how science and policy mingle with people's attitudes, and particularly interesting to hear a bit more about the, I guess, the lack of correlation that you talked about between knowledge and acceptance. And I think you're right in just talking about how there's definitely a lot more work to be done in this space to understand the issue. So thank you for giving us that overview. And thank you to all our speakers tonight. We'll move on to the Q&A component. I see everyone's been busy writing away in the Q&A section. I think just to kick it off, excuse me.
Tasha?
Yes.
Sorry to interrupt. So one question was accidentally moved into the answered section and had quite a few likes. So maybe we can start with that question. It's you'll see it at the top. It's next to open. There's a tab that reads answered in the questions in the Q&A.
No worries. So looking at the question from Simon, is that it?
Yeah, that's it. Thank you.
Okay, so all right, I'll read this one out. It's got a few parts to it. And the panelists, you should be able to see this as well if you want to read it yourself. But I'll read it out for everyone. So why does it depend when it's a choice between IPR of recycled water and desal, but IPR of stormwater is quickly and over simply disqualified or not even considered? And there's a bit of background info. So this is true in the WASA reports and some of the presentations tonight when our close neighbour in Singapore has a stormwater to potable system, and we're investigating these opportunities in Melbourne. So can you explain what your views are on the sources of this industry bias and why can't stormwater be part of the it depends discussion?
Sounds like this is me, Natasha.
I was going to say, Greg, I think this might have your name on it.
Okay. Hey, Simon, wherever you are. So look, the fact is I'm totally biased, and that's why I did it this way. No, that's not it at all. I think the first thing is, in case you sort of answered this question, I mean, tonight's discussion was about indirect potable reuse of recycled water, and I was asked to think about that in the context of comparing it to desal. I think, as I said at the start of the presentation, if we're actually planning what we do for any city, we should be thinking about all options, which would obviously include, you know, whether we could make stormwater to potable into, you know, a viable option as well. I personally think all those options should be on the table. So in the context of just giving a quick overview and giving a comparison between two broad options, that's where the discussion came from about comparing IPR of recycled water to IPR of desal. And I just want to finish by saying one thing. I actually think that it's doing a disservice to stormwater harvesting to use the phrase IPR to describe it. I think we should use some other phrase, because I think there's quite different merits for stormwater harvesting. It's quite a different thing than doing recycled water from wastewater, and I think it'd be best if we didn't sort of stick it under the same umbrella as IPR, and it was considered separately as its own thing.
Yeah, Natasha, if I could make a comment too, I think if you take a one water type approach that says you're going to have stormwater, you're going to have water in tanks from rainwater collection, you've got IPR, DPR, you've got normal potable supply. In a sophisticated future, we're going to use all of those, and we're going to use different amounts of them at different times of the year and at under different resilience environments. And in actual fact, across time, across 20 years, our resilience is changing, but across a year, that mix would change, and our systems need to be able to adapt to do that. And at the moment, we're not very sophisticated there, but I think we need to get more sophisticated in our thinking about how we pull all of those sources together. And as I said, don't just say it's one or the other, but how do we use all of them in a sophisticated way across a year and across different climate scenarios?
Thanks both. I think, yeah, it's a very big discussion, isn't it? There's definitely a lot of factors in considering all of those elements. Got quite a few comments coming up in the chat, which is great to see. I think we might, in the interest of time, we've got about 10 minutes left on our proper Q&A. I'll just try and get through a few more questions. And Greg, I've got another one coming for you. This is the other top voted question. So interested to know why the cost of recycled water for drinking use is almost half that of recycled water for non-drinking. So there's a few comments there already, but if you'd like to add.
Sure. So, hi, Lauren. I don't know if I know who Lauren is. If I do know you, Lauren, apologies. I think the first thing is that I'm not responsible for, and which is, you know, that I was showing you a picture there from a WASA paper for those costs. So I can't speak exactly for where those costs came from, but just in broad principle, what often turns out to be the case when you do work like this, if you actually think about getting a very significant amount of recycled water from dual pipe going to houses, that the cost of putting the pipe in is a very significant cost, and that ends up making dual pipe schemes more expensive than doing potable reuse, because even though you have to do a bit more treatment and that costs you extra money, the cost of the extra treatment is far outweighed by the cost of the additional pipe to do a very, very extensive dual pipe scheme. However, it turns out to be the case, as per usual, that it depends. There's many, many suburbs that use dual pipe, and in those unique circumstances, it turns out to be a good thing to do. So, however, that overall study has come to that conclusion when it's looked at all of the schemes around the place.
That's great. So we've got another question, just on that note, comparing desal to potable reuse. So this time, rather than the cost, David's asked the difference between coastal versus inland. So how do inland cities that don't already have access to seawater, how would you then go about that comparison?
This is from Mr. Sheehan.
It is.
I think David's asking in a way a cheeky question here. I think the answer is very obvious, which is that, you know, for inland cities, significantly inland, seawater desal is not a practical option, and so, you know, potable reuse is a very much more attractive option compared to seawater desal. Only comparing those two in those circumstances. As it happens in Australia, we don't have very many big cities a long way from the coast. Probably the most notable one actually is Canberra, interestingly enough. And that's something I'd certainly advocate. I think if Canberra instituted an IPR scheme, that would be nice leadership from the rest of Australia.
Thanks, Greg. That was a good answer. I did want to ask a question of Anna. So this is one from Michael that talks about perceptions of desalinated water. So 15 years ago that desal water wasn't considered acceptable. So what could we learn from this to address the risks and perceptions associated with potable reuse? If you have any comments on that one.
Yeah, so thanks for that, Michael. Honestly, I haven't actually had a look at any of the data around the perceptions for desal from 15 years ago. But I do know, I have seen studies looking at perceptions of desal water versus perceptions of potable reuse. And people are generally, even though this was before desal was even implemented, and people were generally more supportive of desal over potable reuse. And this is something else I think somebody else mentioned in one of the comments, and it was really that yuck factor, that feeling that oh, I'm drinking somebody else's toilet water, like can't we do better than this? And so I think that still permeates a lot of the discussions. And so what can we learn from that, from desal? I'm probably not the right person to say, just because I'm not well across the desal element, just the potable reuse.
All right, thanks, Anna. Just on that yuck factor question, I did see someone had asked that. How did you go about incorporating that into your research? I imagine that was something that was a pretty prominent factor.
Yeah, and I mean the yuck factor, especially the not in my backyard, is something that's that comes through quite often. And I think that this really does need to come back to looking at the values that are incorporated in these decisions. Why are we putting such a reuse scheme in place? And I wonder how that might have even changed over the last couple of years, whether people might be more accepting of it, because a lot more talk about climate change. The climate marches have happened as well. And so I wonder how much our perceptions change over that time even, and that might start to counter this yuck factor. The other thing that could is perhaps even just having seeing other countries around the world who've done similar things. I wonder whether that might change things too. But it is definitely something difficult to overcome, and overcome without education or a lot of information, which is very difficult to do at the moment, which is a very kind of anti-establishment sort of rhetoric quite often that we see online, which I think somebody else mentioned in there too. So that does make it a lot more challenging.
Yeah, definitely. No easy answers to that one. So I think for our next question, I'm going to uphold the democratic process of the Q&As and go for the next highest voted one. So this question is from Sarah, asking, does stormwater get discounted as a new source of water because it's not considered to be climate independent? And given urban hydrology significantly increasing runoff, is this a short-sighted label? And I know you sort of touched on this already. Just really keen to hear your thoughts on especially the climate independent part. So I think this might be Greg and maybe Peter, if you'd like to input on that one.
Okay, so I had the sense we're running out of time, so I've actually typed an answer to Sarah already.
Oh, have you? I missed that. You're all over
so that's okay. I'll just quickly answer. I think this is a really good example of why these things are actually so tricky, because in practice we do get quite different hydrology, and so harvesting stormwater in the city is not the same as harvesting stormwater in our catchments. And even more importantly, we've got excess stormwater in the cities that we'd like to catch, whereas I'd prefer to leave more water in the rivers. So I think it's a good thing to do. Is it entirely climate independent? I don't think it is, but that doesn't mean it's not worth doing. So I think all of these things need to be in the mix. And one of the issues we have with stormwater harvesting is actually the fact that it is inconstant unless we build a very big dam somewhere in our cities, which is difficult. And so it's always going to have to be combined with some other source, or effectively it's similar in my mind to solar or wind. It's a really good thing to do, but you've got to find other things as well to balance out the network, if I could put it that way.
Yeah, thanks, Greg. Thanks for answering that one twice. So the next question, I think we've got time for a couple more before we hit our 7 p.m. deadline. So this is from Peter asking if you think the growing weight of social media influence with conspiracy theories could impact on the rate of acceptance of PR nowadays. So feel free, any of you, to jump in on this.
It's actually quite interesting because I just recently just wrote a paper on this exact topic because it's fascinating in itself. It's under review at the moment, but I would have said yes, definitely in answer to his question. I mean, conspiracy theories really are all about that underlying distrust in authorities. That's kind of really what underpins a lot of these. And therefore, it really does render it quite difficult to justify decisions in a climate like that, and to convey important information, especially when you don't have any control over how that information is being distributed, in what way, especially when it comes to things like social media's algorithms might be set in a certain way where your information might not get, your important information might not actually get out there to the people who need to see it. So this definitely is exacerbated by the current information channels that we use, but also that increasing distrust that we're seeing of scientists as well.
Yeah, definitely. That's a very great answer. Digna's just reminded me that I've got a couple more slides to get through before 7 p.m. So these will take a couple of minutes. So we'll just pause the Q&A there for a short moment. So before we let you all go, we just wanted to let you know about a couple of other events that are coming up for the Victorian branch. So we've got the AWA Victorian Water Awards. They're open at the moment and closing 8th of October. Also include a student water prize category among many others. And we've got our next webinar in a similar vein to tonight's one, still planned to be a webinar. And that one is on Melbourne's underground water challenges. So that'll be exploring the groundwater challenges and lessons learnt through some of Melbourne's large-scale tunnelling projects. So that one should be pretty interesting if you could join us. And the website's there, I think, if you want to check that one out. And then lastly, just wanted to give a quick shout out to the ongoing support of our principal members. So we're a volunteer committee and a member-based organisation, so we really rely on the support of these members to help us run these events, which we love doing, so that's great. Okay, so that was it. That's the end of the formal part. So just in case anyone did have to duck off at 7, I did want to thank everyone for joining us tonight, particularly the speakers, our sponsor, and all of you for attending and asking such interesting questions. So I'll then go and undermine myself. Having said that we're finished, I will now continue the Q&A for anyone who'd like to stick around. So if you're interested, we've got another unofficial 15 minutes before we close this down at 15:15. So feel free to head off if you have to, but you're very welcome to stay and continue the discussion, and we'll just keep going through the Q&As and get a few more in if we can. Unless there's anything you wanted to add, Digna, or we'll just crack on with it.
Yeah, just keep going, Tesha. Perfect.
All right, let's do this. Panel, you ready? Round 2?
Yep.
Okay, so we'll just work through the top voted. I think the first one's been done. So we'll move to the next one from Rod. So this is another one about UPR. So just to clarify, UPR is not accidental. Oh, that was me misunderstanding that. So it could be that too in an incident. Rather, it is quite intentional discharge to a waterway without regard to downstream or subsequent use. So in the Murray-Darling system, and how many town supplies exist downstream of wastewater treatment plants. So discharge of the town or sediment upstream. So, okay, there was not so much a question, more of a comment, but thank you for that, Rod. I've learned something new tonight. Thanks very much for that.
Can I make a comment on that one, Natasha?
Yes, Peter.
Yeah, Rod, I agree. A very large amount of Europe's water and water around the world has got UPR. Even Melbourne has some UPR in it. And one of the things that I believe we should be doing is acknowledging that up front and treating that water to a higher standard, assuming it does have hormones and chemicals and things like that in it. I think the chemical risk there is higher than the pathogen risk for the UPR, because the chemicals are not necessary. They can be more recalcitrant in the system. So a lot of our water treatment systems assume a protected supply, and we probably need to move to more of a one water type model that says our initial treatment needs to be more advanced to deal with UPR, and ultimately at that point we can start to think about the fact that that treatment plant then is not very different from what an actual advanced water treatment plant would be.
Thanks, Peter. That's really interesting. And maybe while you've unmuted, we can go to the next question, which is, you know, noting that plenty of UPR schemes are already happening, but also if we accept that DPR is inevitable, what is critical to success, which is quite a big question, but if you have any comments, that'd be great, Peter.
I think what's critical to the success of any of these systems is demonstrators that engage the community. I think if you look at the history and the learnings from overseas studies, and the one in Perth, is if you don't have a system that engages the community where they can go and touch and feel it, then you're never going to get a DPR system up and running. And therefore, DPR will be cheaper than IPR in a lot of cases, but you've got to go through a process. You can't just say, I want to build it, let's talk about it. You've actually got to demonstrate it and let people touch and feel it, and then move to it over time after people have actually used the water in different non-potable environments, etc. So that engagement piece of not just talking to the community, but actually demonstrating with the community and having the community touch and feel, it's a very important part of moving down the entire recycle piece, I would argue. Otherwise, you'll finish up just having lots of surveys. Not that they're bad.
And Greg, you wanted to add something?
Yeah, I just want to expand on Peter's point, because this is the one thing I'm passionate about. So, you know, that's going to come across at this point. I think whatever new thing we want to do, whether it's IPR, DPR, stormwater to potable, whatever it is, there's a very, very simple thing it needs. We need time. And what we can't afford to do, if we want to do the best we can do, whatever that might be, let's assume it's IPR for the sake of argument, or DPR, we can't wait until there's a crisis and then hope to get something new and innovative across the line with the community. We've got to put the time in over the long term, whatever long term is. We've got to make sure the community's on board with these things, and we've got to make sure we're making the right decision. And to me, that's the number one barrier at the moment, is we're not putting in the long-term investment with our communities to look at all of these options in depth. And I think until we do, it's going to be difficult to get there.
Yeah, I think that's a valid point, Greg. And Anna, you might have something to add on that based on your community experience.
Yeah, I mean, I still think it's also about the way that we see ourselves in relation to the community, especially with the current trends in the way that information is taken on board. And particularly with that is that kind of approach of that paternalistic sort of approach. People don't really take that very well, we know, in discussions. So saying, I'm the expert, you have to listen to me, we know is not taken on that well, even if we're saying it's really, really safe, you know, don't worry, just trust us. And it's also saying, well, you know what, your values actually do matter as well. So asking the community, well, would you value something like this? You know, is this sort of level of sustainability something that you want to see? It's all about the, you know, the cities and the places that we want to make. And the best gauge of that is the community. So that's definitely where I'd say we should start. And as experts, I think we should actually be the kind of the bearer of information rather than be the be all and end all. We have very, very important insights, but also not all the insight.
Yes, I think that's a great point to remember, isn't it, Anna? If you want to hang on for another sec, Anna, the next top question is directed at you, and that's about interest in observing the reaction of the public to a recent water quality incident in Melbourne. So, Anna, what do you think we can learn from the water industry's communication regarding this, and if there's anything we could translate to communication regarding potable reuse? I think you've talked about some of the high-level issues about that, so if you've got anything to add on this one.
Yeah, I mean, I think that in that circumstance, the water authorities did a great job with, they weren't shy about straight away getting onto the media and saying this, you know, issuing the boil water alert. And I know that back when I used to work in strategy and communications, that would be a huge thing to even start to, you know, implement something like that. So I know the barriers that must have been in place to even put that out there. But overall, people took that message and they did something about it. And that was the most important thing. It did spread a little bit further. I had people in my apartment building where I live in Carlton messaging saying, should we be worried? Should we not drink our water as well? And really sort of, and I wonder how much of that is just that kind of fear. But then as soon as the boil water notice was removed, people just went back to how they were very, very quickly. I also wonder the impact that the pandemic may have had on there, with the underlying anxiety and that already being there, and that kind of feeding into perhaps how people may have been feeling about the boil water notice.
Yeah, there could have definitely been a bit of priming there.
Yes.
Potentially. Yeah, that's a good point. So let me just look. We've still got quite a number of questions. I'm afraid we probably won't get through all of them tonight. The latest one to be upvoted, so it's related to climate change. So I wonder if the questions had the context of the weight of the climate adaptation challenge and the relative cost of living challenges. So does the question need context so people can make judgments about the broader trade-offs, which include risk perception, affordability, water security and livability? So if any three of you'd like to answer, Anna, you've got your mic ready to go.
Oh, okay. Is it
put you on
my own fault for not turning it off early enough? No, I'm happy to have a crack at this. I guess to say that definitely about the broader trade-offs. So I'm just having a look, bringing up the question again. But so sorry, I'm going back to the question. I think it's already getting late night for me. But it's looking at the broader trade-offs, isn't it? Because I've just lost the question in my feed. And do people need to know about that in terms of their risk perceptions? And that?
Yeah, I think it was about I've lost it from my feed as well. The broader context, I think, in which you're looking at these things and how you kind of would make those trade-offs.
I think that, I mean, I would argue that a lot of I think it's also about our own risk perceptions. I know from the research that I've done, are heavily individualized and do rely on a number of psychological factors that we carry over from experience and our own values too. So when we're doing trade-offs, we are constantly making value assumptions and value calculations based on what matters to us. And so I wonder how much that would also factor into that. I'll let the others go have a go as well.
Yeah. Oh.
Sorry, I was on mute then. Wouldn't be a Zoom meeting if I tried to speak without mute. Sorry, Peter, go.
No, I'll leave it, Natasha. I think it's, perhaps jump to another one. Yeah.
So this question is from Lachlan about the step change in inflows. So I think you wanted to make a comment on, did we have a reason for the step change in inflows, as it's a common observation in Eastern Australia post 1998, sorry.
So, I mean, I think this is a really tricky question from Lachlan, in the sense that this is, you know, like the deep question of our time, isn't it?
Yeah, it's a big question.
Right. To what extent can we attribute changes that we observe in a relatively short time frame to the influences of things like human activity and climate change? And my understanding of the science, and I'm sure there's people on here who know more than me about the science here, but my understanding is that we think that climate change has been a contributor to the changes, and the models predict that we'll see those changes. However, I think there's another factor in here, which it is also the case that inflows are variable. And therefore, I think one of the things we're noticing when we look at what's happening in our cities is the degree to which we're vulnerable to those variabilities.
Yeah, one of the other issues, obviously, is that, and it's come out of modelling during the Millennium Drought, is that we predict that it's obviously not linear. As you get a change in rainfall, say of 10%, you might get a change in runoff of 30 to 40%. One of the modelling things from the hydrologists during the Millennium Drought was that their predictions were even worse than that. In actual fact, the hydrological models for a dry, parched environment are not, they're overestimating runoff, and we even get even less. So in other words, Perth saw that, you know, a 20% change in rainfall caused about a 70% or something greater change in runoff. And that's a major, so small changes in rainfall and the type of rain can have major effects here. Not a hydrologist, so got to be careful.
No, that was a good answer, thank you. I think we're getting through our questions. We've got a couple of comments. Comment about behaviour change, something similar to the way we did seatbelt legislation as a behaviour change program, is an interesting one. And I think, looking at the time, I think we might have to leave it there, unless anyone's got any final comments they'd like to add, any of the speakers. Otherwise, I'll thank you all very much for your time tonight. It's been a really interesting discussion on what's a very complicated topic. So I think between the three of you, you've done a really good summary of, I guess, explaining why we have this water security challenge and how this has become a potential solution to a very big problem. And then you've gone through, I guess, some of the technical issues and all the components there with risk management and water quality treatment, and then had a really good conversation over the top about, I guess, the social aspects of it all. So I think it's been a really interesting conversation discussing the intersection of all of those elements that very clearly highlight why it's such a complicated and complex issue here. So thanks again to all of you for joining us tonight, to the speakers and to our sponsors, and thank you very much to all our participants as well for joining us tonight. So have a great evening, everyone, and we hope to catch you at the next webinar soon.
Thank you all.
Thank you.